Welcome to the channel. Today we are talking about 7 important reasons out of 21 as to why motorcycle beat scooters through an engineer's perspective. The 7 reasons we are going to discuss are manual transmission efficiency, higher engine performance, faster acceleration, better highway cruising, superior hill climbing ability, stronger load carrying capacity, better suspension under load. This is our video number 119 in total, and this is part 1 of the series for the comparison between motorcycles and scooters. If you have not yet subscribed the channel, please do so as early as possible. The first important reasons we are going to discuss is manual transfer transmission efficiency. That is direct mechanical power transfer. Motorcycle uses a manual gearbox that provides direct mechanical power transfer with minimal energy loss. This results in a better torque delivery, stronger acceleration, and improved fuel efficiency at highway speeds. There is a rigid metal on metal connection, whereas in scooter, this build-up setup inherently suffers from friction losses and slight slippage, meaning energy is wasted as heat rather than burning the wheel. Better torque delivery and stronger acceleration. Motorcycle selects the gear ratio optimized for the current situation. It ensures maximum pulling power when climbing steep inclination. Whereas in CVT limitations, whereas CVT transmission of scooters, it takes a moment for the pulleys to adjust, which can cause a slight lag or rubber band effect when you twist the throttle, missing that immediate snappy torque delivery. The third element of manual transfer efficiency is improved fuel efficiency and highway speed. Motorcycles, while while moving at 60 plus mph per hour or 100 per hour, a motorcycle rider can shift into a tall overdrive top gear. This drops the engine's RPM significantly while maintaining speed, saving substantial fuel, and reducing engine wear. Because CVT is restricted in case of scooter, the maximum physical width of its pulley, it often runs out of taller ratio at top speeds. This forces a scooter engine to revolve much higher and sustain highway speeds, which increases fuel consumption and subjects the engine continuously at higher stress. This can be explained through this infographics. Motorcycle manual transmission is direct mechanical power transfer. Its efficiency is more, it has minimum energy loss, more power reaches the road. Where in case of scooter, belt-driven power transfer, it passes through a belt between pulleys, friction and slightly slippage, there is a power loss. And then better torque delivery, a stronger acceleration. Motorcycle performance is better with strong acceleration and better control. CVT response in case of scooter, delay, rubber band effect, pulleys adjust automatically, slight delay before power builds. Improved fuel efficiency, better mileage. In case of motorcycle, and in case of scooter, limited tall ratio in CVT. Engines runs at higher speed to maintain speed, more fuel use, and engine stress. The second important feature for comparison is high engine performance. Motorcycle provides quicker acceleration and higher top speeds. Motorcycle consistently delivers high performance metrics. So, in case of high engine performance, the first factor is high RPM capabilities of motorcycle, allowing the engine to breathe better at higher speed and generate more horsepower. It is aggressive in tuning. Electronic control units and fuel injections are tuned for maximum power output and snappy throttle response. Then, liquid cooling versus forced air cooling. Motorcycles are far more likely to feature large front-mounted liquid radiators or prominent cooling fins exposed directly to the oncoming wind. Thermal management. Better cooling allows motorcycle manufacturers to run higher compression ratio inside the combustion chamber. And engine placement. A motorcycle engine is rigidly mounted, optimized sweeping exhaust system, and large air boxes. Scooter. Scooter, in case of scooter, the tight space severely limits the physical size and geometry of the intake and exhaust tracks, which ultimately caps the maximum power the engine can breathe in and push out. This infographic says all these features related to higher engine performance are shown. That is, advanced engine design in case of motorcycle with far higher RPM capability, multi-valve, four valves, and aggressive tuning for maximum power, resulting in most of the cases, 13 to 15 HP if it is 150cc motorcycle engine, and in case of scooter, 9 to 11 HP. Superior cooling. Motorcycle cooling is better heat control. It allows higher compressive, more power and torque. In case of motorcycle, 12 to 14 Nm, and in case of scooter, 9 to 10 Nm. Likewise, structural advantage. Optimized motorcycle is optimized air box and exhaust design. Engine certainly mounted, centrally mounted in frame. In case of a scooter, limited airbox and exhaust space, engine in swing arm tight packaging, resulting in top speed of the motorcycle at 110 to 120 kilometers per hour, and in case of scooter, 90 to 100 kilometers per hour. The third factor is faster acceleration. Motorcycle accelerates faster than CVT-equipped scooter, especially during overtaking and highway merging. The motorcycle manual gearbox provides a distinct edge in acceleration over scooter CVT. Motorcycle, for the instant power on demand, this instantly forces the engine into its peak power band, high RPM, delivering maximum horsepower and torque to the rear wheel, the exact millisecond, and throttle is twisted. In case of CVT, there is a rubber band effect. When you suddenly open the throttle wide on a scooter, there is a distinct brief delay while the weights slide out and pulleys adjust to the new load. This creates a delayed, elastic acceleration curve rather than immediate punch needed for tight overtaking windows. contour over the power band. Motorcycle, in case of motorcycle, you can intentionally hold a gear all the way up the red line. In case of motorcycle, the system is programmed to find a balance between efficiency and speed, meaning it will often upshift to a more economical ratio sooner than a rider would prefer during a high demand performance maneuver. Can further be explained through this infographic. Faster acceleration, instant power when you need it. In case of motorcycle, downshift and get instant power. Engine goes to high RPM immediately. That is instant power on demand. In case of scooter, open the throttle wide and but CVT takes time to adjust. There is a delayed response. Then power band control. You control the engine. Hold the gear to the red line for a maximum acceleration, as shown in this graph. In case of scooter, CVT controls the engine. Upshifts early for efficiency, not a maximum power. Coming to a quick overtime overtakes a confidence. Immediate punch when you need it most in case of motorcycle, and in case of scooter, noticeable lag due to a rubber band effect can cost critical seconds. The fourth factor we are using for comparison is better highway cruising. Motorcycles are generally designed to sustain higher cruising speed with lower engine stress. Number one factor, that is lower power stress, lower engine stress. At highway speed, a motorcycle rider can shift into a top gear. This mechanical advantage allows the engine to drop its RPM significantly while maintaining a high road speed. In the case of scooter, engine must run at continuously higher RPM near its limit, placing the engine under constant thermal and mechanical stress. Aerodynamics and stability. Motorcycle typically use 17-inch or larger wheels which generate higher gyroscopic stability. Gesture geometry. The balanced weight distribution cuts through wind resistance cleanly, whereas a scooter step-through frame and rear-heavy engine placement can create aerodynamic instability and high-speed buffeting. Ergonomics. Motorcycle allows for a natural riding astride posture where the rider gives the fuel tank with their knees distributing weight evenly between the seat, foot pegs, and handlebar. Scooters pull the rider weight directly onto the lower back in a feet-forward sitting position, which can lead to fatigue over extended intercity commutes. Here, this factor, that is better highway cruising, is explained through infographics. Motorcycle, lower engine stress, tall top gear override, lower RPM at highway speeds, less vibration, less heat, and better for long-term distance. In case of scooters, high engine stress, CVT reaches a limit early, high RPM to maintain speed, more heat, more wear, fatigue on long rides. In case of motorcycle, aerodynamics and stability. It has superior stability with larger wheels that is 17 inches plus, higher gyroscopic stability, tracks state stable at speed, less affected by wind and road. Here in the case of scooters, less stability, wheel size 10 to 14 inches, more more problem at higher speed, more affected by wind, less less planted feeling. And in case of ergonomics, in case of motorcycle, natural riding postures, weight distribution, better control, and less fatigue. In the case of scooter, feet forward position, weight on a lower back, less control, and more fatigue. Now come to the fifth factor, that is superior hill climbing ability. Manual gear of motorcycle selections allows rider to multiply engine torque when climbing steep and gradients. When tackling steep mountain roads or carrying heavy load, the motorcycle manual transmission provides a major advantage in maintaining climbing momentum. Let us go through the detail. Number one, mechanical torque multiplication. Motorcycle in a low gear like first or second mechanically multiplies the engine torque through precisely matched steel gears. In case of scooters, the belt is forced to handle immense continuous friction, causing it to run incredibly hot. And then slippage. Under extreme load, the belt can slightly slip within the pulleys, wasting pressure, engine energy. Preventing gear hunting and momentum loss. In case of motorcycle, the rider can anticipate a steep hill ahead, downshift early, and maintain a steady RPM. In case of scooter, the mechanical rollers and spring can get caught gear hunting, constantly shifting the belt back and forth, trying to find the right ratio. Here is the infographic related to the superior hill climbing ability. Maximum torque on claims. Low gear multiply torque, delivering maximum power to the rear wheel in case of motorcycle. In case of scooter, belt friction and heat under load waste power and reduce climbing ability. 10. Steady power, no lag, maintains momentum. Rider downshifts early and hold power steadily through the climb. In case of scooter, CVT constantly adjusts, causing lag and loss of momentum. And then strong, stronger pull every time. Handles heavy load. Motorcycle is stronger pulling power with passenger and luggage. Where in case of scooter, high heat, slippage, and power loss with extra weight. The sixth factor for comparison between motorcycle and scooter is stronger load carrying capacity. Motorcycle generally feature stronger frames, higher gross vehicle weight rating, and more robust suspensions. Motorcycle possess clear structural and physical advantages over scooters. Now, number one factor related to stronger load carrying capacity is higher rigidity chassis design. Motorcycle typically utilize robust frame architecture such as diamond, perimeter, or trellis frame constructing from high tensile steel or aluminum tubes. Scooter predominantly rely on step-through open frame design that creates open foot space. Engineer lost the structural top tubes, meaning the chassis is more prone to flexing under extreme weight loads, lowering their overall gross vehicle weight rating. The comparison, that is motorcycle, we have motorcycle, we have three type of chassis design, that is a diamond frame. Here is the parameter frame, that is a twin spar, and trellis frame, that is a terrace frame in case of motorcycle. All these three designs have their own advantages and disadvantages. The diamond frame has minimum manufacturing, lower cost, good weight, and in case of it has ease of repair. Where in case of parameter, the rigidity is very high, and of course, high speed stability and and cornering cornering precision is very high. In case of trellis frame, it has it has ease of repair rating is the best. Plus its rigidity, plus its weight, and then of course high speed stability and cornering precision. Regarding stronger load carrying capacity, the second factor is robust suspension system. Motorcycle provides immense structural strength against heavy front-led loads and hard braking forces. As motorcycles use sturdy telescopic or inverted force clamped securely by a dual triple tree assembly at the top and bottom of the head tube. Rear suspension. Motorcycle rear shock absorbers are attached to a dedicated swing arm and mounted close to the center of the chassis, offering progressive damping and better weight distribution. Then, balance weight distribution. When you add a passenger or luggage over the rear axle, the total weight remains relatively balanced between both the tires. Because the scooter engine, transmission, and drivetrain are clustered entirely over the rear wheel, adding extra cargo or passenger pushes the center of gravity drastically backward, which is the disadvantage of the scooters. Here the infographic. In case of in case of frame, the motorcycle frame is rigid chassis, which is of high strength, closed frame handles, heavy load without flex. Then in case of scooter, step through design, more prone to flex under heavy load. Now coming to the suspension, motorcycle suspension are robust suitable for longer travel, stronger forks and shocks for heavy loads and rough roads. In case of scooter, short travel suspension, lighter forks and engine as swing arm reduces load handling. And the third factor, balance weight distribution. Engine centered, weight stayed balanced even with passenger and luggage. There is in case of scooter, engine and powertrain at rear make front front light and unstable with extra load. Therefore, in case of motorcycle, more load, more confidence, and of course, more miles. Seventh and last factor which we are using for comparison today is better suspension under load. Dual shock or advanced monoshock suspension or motorcycle systems provide improved stability, ride comfort, and handling when carrying passengers or luggage. One factor is progressive linkage monoshocks. Under light load, while many modern motorcycles use a central monoshock connected to a progressive linkage system, which under light loads remains flush and comfortable under heavy loads. It naturally stiffens up to prevent the suspension from bottoming out. Dual shock stability. Traditional or classic motorcycle utilize dual shock absorber mounted symmetrically on both sides of the rear wheel. This balanced setup distributes heavy passengers or luggage weight evenly across both sides of the chassis, minimum, minimizing side-to-side chassis twist. The upsprung mass advantage. In case of motorcycle, the heavy engine and transmission are bolted rigidly into the frame, completely isolated from road bumps by suspension. Because the rear suspension only has to control lightweight swing arm and wheel, it can react incredibly fast to bumps, keeping the tire firmly planted even when the bike is carrying a lot of weight. In case of scooter, on most scooters, the entire heavy engine and transmission unit is built directly into the rear swing arm. This creates massive upsprung mass. The suspension has to move weight of the whole engine up and down every bump. Now, the adjustability of the weight changes. Motorcycle shocks are generally designed with accessible preload adjustment, and scooter typically feature simpler, light-duty springs with limited or no adjustment range. This factor, that is better suspension under load, is further explained through this infographics. Number one factor, advanced shock architecture. Motorcycle have monoshock with linkage, progressive damping, and dual shocks, balance and stable. In case of scooter, single shock with engine as a swing arm, less stable under heavy load. Number two, unsprung mass advantage. Heavy engine fixed to frame, unsprung mass. Light swing arm responds quickly to bumps. Here in case of scooter, engine and transmission move with wheel, more bumps, less grip under heavy load. Adjustable load changes. Cycle shocks adjust preload, easily restore ride height and stability. In case of scooter, limited or no preload adjustment compromise ride and handling. Therefore, heavy load can be handled with the motorcycle with no problem. With this, we conclude our today's discussion on the subject of why motorcycle beat scooter using 7 important features. Stay tuned. See you again with the videos on similar topics related to automobiles, motorcycle, scooters, and auto rickshaws. And if you have not yet subscribed the channel, please do subscribe as soon as possible. Thank you and thank you very much.